Hello everyone. Today we are going to discuss about the fuzzy sets and functional membership using a design thinking approach. So this topic is belonging to AI techniques for electrical engineering in fuzzy logic unit. How the fuzzy logic will helps in managing microgrids efficiently, especially when dealing with uncertain renewable energy sources and varying load demands. And today's topic for discussion including design thinking. The design thinking have five stages, that is empathize, design, ideate, prototype and testing. So in this we are going to cover about the functions of the microgrid energy management system and comparison with microgrids with conventional power systems, and finally explore fuzzy sets and membership functions and their role in microgrid optimization.
Next topic is topics for discussion. In this presentation, we will discuss the application of fuzzy sets and membership functions in microgrid management. First, we will understand the concept of microgrid management and its importance in modern power system. Then, we will look at the major functions performed by the energy management system, commonly known as EMS. Next, we will introduce fuzzy sets and see how fuzzy logic helps in handling uncertainty in power systems. Finally, we will study membership functions and their role in optimizing microgrid operation. The next topic is overview of microgrid management. A microgrid is a small scale power network that can generate, store and distribute electricity locally. It consists of distributed energy resources such as solar panels, wind turbines and diesel generators along with energy storage system like batteries and various electrical loads. A microgrid can operate in two modes. The first is grid connected mode where it works together with the main utility grid. The second is islanded mode, where it operates independently during grid failures or power outages. The main objective of microgrid management is to maintain a balance between power generation and power consumption. It also aims to ensure reliable and stable power supply while optimizing energy usage and reducing operational costs. Effective microgrid management becomes especially important when renewable energy sources are used because their power output can vary depending on environmental conditions. And the session will be continued by Kumar.
Now let's see the empathize and define part. While empathizing it has a rural college campus faces a frequent power cuts that affects laboratories and study halls. By this, students require reliable electricity for effective learning and safety. Diesel generators are expensive, noisy, and cause environmental pollution. So, so the problem for definition will be how can continuous, affordable, and clean energy be supplied locally? Direct solution direction. Implement microgrid management with smart control techniques. What are the functions of, let's see the functions of microgrid energy management system. So the main functions are listed as real monitoring of generation, storage and load demand, load forecasting and renewable energy prediction, voltage and frequency regulation, intelligent scheduling of energy sources, also decision making under uncertainty using smart algorithms. While comparing with conventional power system, the control will be centralized for conventional system, and for microgrid it is decentralized or smart. Energy flow will be one way in conventional system, and it is bidirectional in microgrid. Generation. The generation will be predictable in convention system, and in microgrid it is renewable and variable. Flexibility. Conventional system has flexible systems. Microgrid has high flexible compared to conventional system. Fault handling. In conventional system, the fault handling depends only on the grid, but in microgrid, it has the capability of self-healing. By this conclusion, conventional methods are rigid, but microgrids require adaptive intelligence.
Introduction to fuzzy sets in microgrid control. Fuzzy set, a mathematical approach to handle uncertainty and impressions. Unlike classical logic, 0 or 1, fuzzy logic allows partial truth values between 0 and 1, used in microgrids because renewable energy is unpredictable, load demand is not exact. Helps in human like decision making for power control. Example, instead of saying load is high, fuzzy logic says load is 0.7 high and 0.3 ideate by designing a microgrid using solar panels, batteries, main grid backup. By adding energy management system to monitor load, generation and storage. Unlike conventional system, allows bidirectional and flexible control. Uses fuzzy logic to handle uncertain solar output and changing demand. Membership functions decide when to store energy, use battery or draw from grid. Functional membership and its role in microgrid optimization. Membership function defines how strongly an input belongs to a fuzzy set. Common membership types includes triangular, trapezoidal, Gaussian. Inputs used in microgrid fuzzy controllers are state of charge, battery, power demand, renewable output. Output decisions include charge, discharge battery, switch generation sources, maintain voltage stability. The session will be continued by Janardhanan.
The next slides are prototype and testing. Prototype build a small campus microgrid with EMS control. Program fuzzy membership rules for load level. Example low, medium, and high. Testing. Check operation during peak load and low sunlight conditions. System automatically balance power reduce outages and diesel usages. Result reliability, efficient, and smart. Then summary. Fuzzy logic is a decision-making technique that handle uncertainty by using values between 0 and 1 instead of only true or false. 1 contain true and 0 contain false. Membership function. A membership function defines the degree of which an input belongs to fuzzy set and assign a value between 0 and 1. Types of membership function. There are triangle, trapezoidal, Gaussian, sigmoid, bell-shaped. And the applications are motor control, home application, traffic control, and industrial automation. Thank you.